Hello everyone. Another case study based question tested in 2026 cbse board examination. Two vertical light poles of height 22 meters and 16 meters stand on the opposite sides of a 20-meter wide road as shown in the figure. Two ladders of length L1 and L2 are placed from a common point R on the road at a distance of x from the smaller pole. Based on the above information, answer the following questions. Express p of x is equal to L1 plus L2 in terms of x. Find p dash of x. Find x for which L1 square plus L2 square is minimum. Let's try to understand the question. Let's try to draw the diagram once again. There is a pole of height 16 meters and there is another pole of height 22 meters. The width of the road is equal to 20 meters. There is a point R. From there you are keeping two ladders. One is of length L1 and the other is of length L2. So this is of the longer ladder is L1, the other one is L2, and we are asked to find out P of x, which is equal to L1 plus L2 in terms of x. So L1 this is x, this is given as x. So from this diagram we can understand, we'll use Pythagoras theorem. L2 is equal to root of 16 square plus x square, and L1 is going to be root of 22 square plus this length, this small length is going to be 20 minus x. 20 minus x the whole square. The question is to find p of x in terms of x, which is L1 plus L2. So it is going to be root of 16 square plus x square plus root of 22 square plus 20 minus x the whole square. This is the first part of the question. Find out p of x in terms of x. The second part of the question is find p dash of x. You just have to differentiate it as it is. Derivative of root of any term is 1 by 2 root 16 square plus x square into derivative of 16 square plus x square is a 2x. Plus derivative of root of this is going to be 1 by 2 root 22 square plus 20 minus x the whole square into derivative of this term is going to be 2 into 20 minus x into minus 1. Because when we use chain rule, we have to differentiate 20 minus 6, that gives you a minus 1. Maybe we will rewrite this expression because that is going to give us a mark, which is x divided by root of 16 square plus x square minus 20 minus x divided by root of 22 square plus 20 minus x the whole square. This is the second part of the question. The second part of the question is, if p of x is L1 plus L2, find the value of p dash of x. Then the third one is, find x for which L1 square plus L2 square is minimum. So we'll find out, let me call that as f of x. Let us call f of x is equal to L1 square plus L2 square, which is 16 square plus x square, the square root will go away, plus 22 square plus 20 minus x the whole square. We want to minimize this, so let us differentiate this. Derivative of this will give you a 2x from here. 22 square when you differentiate will become 0. 16 square when you differentiate will become 0. This will give you 2 into 20 minus x into minus 1, which is equal to 2x minus 40 plus 2x. So to find maxima minima, to find minimum value of L1 square plus L2 square, the minima is f of x, f dash of x to be equated to 0. That gives you 4x is equal to 40. That gives you x is equal to 10 meters. That means the ladder should be placed at the midpoint. X equal to 10 meters means this is 10, this is 10. So when you place the ladder, this ladder and this ladder exactly at the middle of the road, L1 square plus L2 square turns out to be minimum. Let us find out the second derivative and justify it. F double dash of x is going to be 4, which is greater than 0. Therefore, when x is equal to 10 meters, L1 square plus L2 square is minimum. So the third part of the question is to find out the value of x for which L1 square plus L2 square is minimum. When x is equal to 10, L1 square plus L2 square is minimum. Then there is a choice question. If 22-meter long pole is also replaced by a 16-meter long pole, at what distance from either pole should the ladders be kept so that the sum of the squares of the lengths of the ladders to reach the top of the pole is minimum? Again, we need to minimize L1 square plus L2 square. The same question with a small difference. This is also 16 meters. This is also 16 meters. And this is given to be x. So this is going to be 20 minus x. And this is going to be L1 and this is going to be L2. They want us to minimize L1 square plus L2 square. This is the third subdivision B. Let us call f of x is equal to L1 square plus L2 square. L1 square is 16 square plus 20 minus x the whole square. L2 square is 16 square plus x square. So when you find out the derivative of this 16 square and 16 square will become 0. So it doesn't really matter whether you have a 16 square plus x square or a 22 square. See, we have 16 square plus x square, 22 square plus 20 minus x the whole square. The only difference in the other subdivision is in the place of 22 square also you have a 16 square. So when you differentiate, anyway whether it is 16 square or 22 square is going to become 0. So this will give you 2 times 20 minus x into minus 1 plus 2x. F dash of x is equal to 0 will give us same result. X is equal to 10 meters. That means irrespective of second derivative is obviously going to be f double dash of x is going to be 4, which is positive. Therefore, even if you change the height of the ladder, whether it is 22 meters and 16 meters or both are of height 16 meters, the lengths of the poles do not matter. The point where the ladder have to be placed so that L1 square plus L2 square is minimized is exactly at the midpoint of the width of the road. So 10 meters on this side and 10 meters on this side. The height of the poles do not matter at all, whether it is 22 and 16 or 16 and 16. These numbers do not play a role. So the answer to the last subdivision of the question is the the pole, the what distance from either pole. So it should be exactly at the middle of both the poles, middle of the road. Should the ladders be kept? Both the ladders have to start from the middle of the road so that the sum of the squares of the lengths of the ladders um, needed to reach the top of the pole becomes minimum.